So a few of us are gonna get up and talk a little bit about what we're doing in the realm of software-defined storage. We've talked and touched on a couple of these things that at the last session. So we won't try to really review some of the stuff we did. We'll touch on it some just to make sure everybody's grounded a little bit, and then we'll try and go a level deeper and maybe bring up some of the stuff we didn't get a chance to talk to at the last session. So Dave Leone and Gary Gumenow will also be up here at different parts. I'm Nate Marshak. So kind of hop in and kind of give you just
Wait, we needed to read that.
yeah. Funny story. I actually, terms and conditions bit me once. On one of my iPhones, it broke. I wasn't able to sync it because they'd changed, they'd upgraded iTunes or something, so I couldn't sync it. And Apple actually, one of the guys in support actually said, well, did you read the terms and conditions? I said, no, whoever reads the terms and conditions? So we're going to talk about CAS and DSS, cache acceleration software, differentiated storage services. We'll talk to Ceph, what the work we're doing there, some of the work we're doing in Swift. We'll talk a little bit about Copperhead and the effort we have going on there. And then we'll touch on the Storage Performance Development Kit and NVMe over Fabrics. We'll do a demo on that. So I know you guys had some interest in some of the numbers we have. We'll have an actual demo with really, really incredible performance numbers using Intel SSDs and doing NVMe over Fabrics. Okay, so why software-defined storage? What's driving it? Why does Intel have an interest in it? So what we're really doing is looking at how our components can best help end users. Because obviously data is the business. Talked a lot about bit rot, silent data corruptions, right? Nobody likes those things. Their data is important to them. So, SDS is kind of being driven by a number of different factors. But one of the key points, in addition to the media transformation, is it's essential to modernizing our storage, right? We talk a little bit about traditional storage, and what scale up was and what scale out is. Software-defined storage really focuses on modernizing that storage, and it's really important at this point because data is exploding that we have.
We actually learned that it really is exploded in the last session.
Yeah, that's right. Those neurons are pretty dangerous. You got to watch out for those guys.
Okay, that's funny right there.
Yeah. But it's important that it's flexible and cost effective, right? Because there's so much explosion of data. It's important that we find new ways.
Who does that?
That we find new ways to store it, in a cost effective manner. And then ultimately, there are, new storage architectures, right? Scale out has been around for a little while, but it's really starting to hit mainstream. There's a lot of products that scale out. There's a lot of open source projects that are, focused on scale out, and obviously proprietary. So this is just kind of a quick overview of all the areas where Intel is getting involved, and what our assets are that apply to software-defined storage. You kind of see across the bottom here, we have really more of the hardware-oriented aspects. Our processors, memory, non-volatile memory, and we have Quick Assist technology, which we talked to at the last session, and then obviously PCI Express and networking. And as you move up, right, you start to see some of the software efforts that we have, and where we're contributing either directly in open source, or in proprietary ways. So we'll talk to SPDK, as we mentioned. We'll talk to some of the work we're doing with Ceph and Swift. We won't touch on our intelligent storage acceleration library today, but there's a lot of cool things there. It's one of those things that helps do math really well.
Are you going to talk at all about specialized processors like the Xeon D or the upcoming ASIC?
Actually, our demo is the one that you'll see later is using a Xeon D.
Okay, good.
So we'll have some slides for that. But yeah, I know with ISA L, one of the things we focus on are complicated math routines like erasure coding. We can do 6 gigabytes per second on a single core using ISA L on a V3 Xeon processor. And we'll talk a little bit about some of the stuff we're doing on the management side, or kind of more of tools side and enabling for software-defined storage solutions.